hungry for more proof in your life? So here we are at your service. Okay. Factorial identities is the topic of the day. And this is going to be good practice. Really, this is a vehicle. This is a good vehicle for you to like prove things. Also a good vehicle to bring you more like algebraic power in your life. I hope really that this helps you feel more comfortable simplifying fractions and doing algebra, right? And knocking things out and working with factorials in an algebraic setting, which you haven't really done yet very much. So the one refreshing thing I think you'll find here, though, is that unlike proving identities in trig, where we had a whole cadre of identities you had to know in order to do your work, there's only one identity, underlying principle. Only one principle today. Are you ready? The one fact you have to know about factorials, which you already, I think, know. We're just putting it on the page here. And that's this, right? This is the only piece of machinery we're going to use all day long. N factorial is equal to n times n minus 1 factorial. If you stare at that for a minute, it needs to become obvious to you. I think it will. So take a second to just let that in digest. You can just digest that. And put in your favorite number and verify that it really does make sense. Does it become obvious to you?
Let's put it in negatives.
I mean, apparently Matthew knows this property. He wrote it on the board. Apparently. What's your favorite number, Davey? What's your favorite number?
Mine is 2.
4, yeah. So plug 4 into this statement. What does it say? If n is 4, what does this say? 4 factorial equals 4 times 3 factorial. Makes sense to you, doesn't it? 4 factorial is equal to 4 times 3 factorial, yeah? Yes, right? Do you agree? It could be written this way, too. This is the same property, obviously, right? You could write it that way as well. Can we see why that's really just the same property? The only thing, just to be clear, there's only one thing we need today, and that's this in this box. But there are lots of other ways it might come up, right? So, for example, this way, where instead of n, we have an n plus 1. You have the same principle, though. If you plug in 3, then you get the same thing that Vivian just said a second ago. 4 factorial equals 4 times 3 factorial, if n is 3 there. It also might be helpful to see that you can rewrite this as n times n minus 1 times n minus 2 factorial, right? In some sense, the factorial operates like an et cetera, right? It's kind of like, isn't the definition of n factorial n times n minus 1 times n minus 2 times n minus 3, and so on? Right? That's kind of how we're using this. And you can stop not just here, but anywhere you like, right? Wherever it serves you as we do these algebra problems, yeah.
But that would get you into negatives pretty quickly.
Could, depending on what n is, absolutely.
For example,
let's assume that we're not going to work
set
with
to 2 for the equation you just wrote.
for the equation I just wrote.
3,
Exactly.
and
So we do want to be careful about what Ian said, absolutely. When you're ready, try this simplification here and see if you can rewrite it as just a pure algebraic expression with no factorials, right? So take a moment to do that. Simplify it. And in this case, I think simpler would be for us maybe an algebraic expression that doesn't involve factorials, right? That would be good.
Magic. I am a wizard.
Wait, when you multiply a factorial,
No.
the exclamation point doesn't like go.
No, it only operates on the thing that it is to the right of.
Okay, the top one is n minus 1 times n minus 2 times n minus 3 add 10. Yes?
Can you like cross out do it?
Yeah, you cross some things out if there's something that can be crossed out, absolutely. Our recommendation for those who are still kind of stuck is to expand out the bottom. Expand out the bottom in this kind of manner, right? Expand it out as far as it needs to go.
That's how I wizard did this. So you get like n plus 1 times n factorial. Right above it, we have a way of rewriting because what's the top one when you multiply it? The bottom one is that times n. I should just start drawing this guy.
Help people out next to you. Some of you are like, I had this 3 minutes ago. Some of you are like, right? I have no idea what's going on. Be the helper.
Is it a bad thing if I have sarcastic stick figures in my notes to show how lazy I am in trying to prove things?
In your notes, you can do whatever you want.
I did that. Okay, I did that. But it's all good. Even if I got a 50. Yeah, no, I don't care. Leave me alone. I did that.
Okay. Let me ask you something. How old is everyone?
Good job, guys. Good job. Good job.
How old is it?
4 years.
Oh, this is second year.
Alright, is that what you got? 1 over n squared plus n? Okay. I don't have anything else to say about that. You guys still need to see it at all or no? Okay. Okay. So really, 2 applications of the property we talked about, right? Rewrite n plus 1 factorial as n plus 1 times n minus 1 factorial, and then you see that that cancels out. And that's how these feel, right? Expand these out until they serve your need, right? I would recommend starting with the left-hand side, right? Sorry, that's just my calculator. I'm going to let people prove this. I'll tell you what was on it. And, yeah. Whoa. You can multiply it now.
Because I think number 2. I found someone. And that one number 2.
Use the definition of combinations here, right? If you haven't already. I mean, really, you should love these. You should really love these because we are asking you to simplify, and we've already given you an answer key, right? Like when you simplify, please just make sure you get it, right? That's all. So do your work. See in the end that you get it.
What?
Wait, never mind. It actually.
You do the rest.
Squared.
Use the definition of combinations for each of those, right? Do you know how what n choose r is, right?
Two equals n, QED.
My life is hard.
Never strong. You get n squared plus n over 2 minus n squared plus n.
Why am I
So minus things, so you end up with n squared plus n minus n squared plus n over 2, which gives you 2n over 2, which is n. What do you got n squared?
Cleaning these things up a little bit, what do you have? So you have n plus 1 factorial over 2 times n minus 1 factorial.
When you meant to,
This feels like the problem we just did, doesn't it? Just upside down. Right?
I'm starting over.
Isn't that the problem we just did, kind of?
Yeah.
Expand the numerator out
Oh my god, it's all working.
until you see an n minus 1 factorial appear. You cancel it out of the denominator. Over here, do the same thing with n minus 2 factorial and n, right? Expand n factorial out into its step by definition. What do you get?
you get n squared plus n over 2. What? Subtract n squared plus n over 2 from that, giving you n
Keep in mind that n plus 1
plus
factorial
n
is
over 2, which gives you 2n over 2 because the 2n squared canceled out. As 2n over 2 is the equivalent of n over QED. For facts, you'll do fine. I just need to study for hours and not have any free time. I'll be fine. Give you 2n over 2. You got it. Not a problem. Need any help? Very good. Should be good.
Yeah? Right? I mean,
What is that? What is that right here?
expand that out.
Look upon the magic.
I didn't know what I wrote. No, I don't. Okay. I don't know.
Say 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1.
How's it going? Did you do it?
25 minus 25.
Did you get n?
5, 30 over 2, over 2.
What does that come out to be? N squared plus n minus n squared plus n all over 2. I think I see it. 2n over 2, which is n, which is what we wanted to show. Good. All right. So the other thing that we want to see here too is maybe visually what's happening here too, right? So n plus 1. Let's say n is 4. What does this actually say? If n is 4, it says 5 choose 2, which is 0, 1, 2. So here's 5 choose 2. Minus 4 choose 2, which is here. This 5 choose 2 minus 4 choose 2 is n, apparently. Is that always true?
You know what? I don't need to.
Right, this minus this is that. Is basically what we just said, isn't it? Okay. Right. Just want to make sure, put a visual on this too, right?
I think like the cap to my eraser.
This guy, you mean?
No, go up one, and then go up one times 2
2
factorial.
what is 2 factorial? Compute it and come back to us in a minute. Let's skip this one for now. We'll come back to it if we want, if we have some time. Prove this one quickly because we've already believe it, don't we? Don't we already believe it? What does it say? If we're doing like, whatever, 10 choose 3, if n is 10 and r is 3, then what does this say? This says 10 choose 3 is the same as 10 choose 7, right? So this is the thing we hold sacred that we already kind of feel is true, but we haven't actually done the algebraic legwork to prove it maybe. So do this once and for all for n and r. Show that those really are the same thing. Start with whichever side you like, maybe the right-hand side, I don't know, just because it looks a little more complicated. Not so bad. Whoa, 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 what? No, don't do that. What are we talking about? There are no complex numbers to speak of here. And there's no reason to be
So if you
multiplying by
have n
constants.
minus r factorial, and you multiply by n plus r.
Are you making up rules?
I'm asking if it's the thing.
If you can prove a result, if you can prove a result having to do with that, then I'll accept it. But I don't know that rule necessarily. All I know is the road I traveled. What is the right set of parentheses? What does that end up being there? Just r. So are we done then? Yeah, isn't that just n choose r? Which is the left-hand side. So we're done with that proof. Okay. So that is the proof that is required to make the assertion we made the other day. Technically, right? That is us proving that in general, 10 choose 7 is the same as 10 choose 3 or whatever. So let's try one that's a little bit trickier here. We gotta push you a little bit here. So as before, let me kind of get you off on the right foot here. I might start with the left-hand side, which does look more complicated, and use the definition of factorial. Use the definition of combinations there to write that out. I also encourage you on the right side to just jot down what this is actually by definition. That's n plus 1 factorial over r plus 1 factorial n plus 1 minus r plus 1 factorial. Right? Yeah. Which is, if we simplify a little bit, that denominator. This is just some pre-work here. We get r plus 1 factorial times, what is that? What is that? Close. Just n minus r, isn't it? I just want to say off to the side, have that in the thought bubble, because I think as you do this work, you might not know you're done. Okay? So you'll know you're done if you see this. Okay? So that's what you're aiming for as you do these manipulations. Let's give you, I don't know, a couple minutes here to struggle. I'll try to give you some pointers along the way. some of you are at this juncture in your life and you're staring at your paper and you're wondering what to do next. Am I right? Does that describe you, friend? Okay. So the next thing I might be tempted to do, because I like algebra, is to maybe try to combine these fractions somehow. Right? That's the only hope I have, and in fact my target expression is only one thing, not two. So that would be a good goal. But I'd like us to be as lazy as possible, right? I'd like us to think about, one way to do it would be to okay, well this doesn't have an r factorial, so we should multiply this by r factorial over r factorial so that we have an r factorial on both, right? But I need you to stop there, right there, because think about it. What did you just say? There's no r factorial over here? Oh wait, hold up. Maybe there is. In fact, maybe this already has an r factorial, and what this needs is for this to become an r plus 1 factorial. So what might you multiply this by? If you multiply this guy by r plus 1 over r plus 1, you'll have an r plus 1 factorial on the bottom of both fractions. Do you see it? We're making progress then. Then we still have to think about this n minus r factorial and this n minus r minus 1 factorial, but I want you to think about how that principle might apply again. Again, try to be as efficient or lazy, however you want to say that, as possible. I've said too much. Or two more. I've said too much.
Oh man, how unfortunate. It looks like it's great.
Yeah, is that right? The same principle applies. So that suggests something else you could multiply by. Yeah, and minus r.
I ran out of line, guys. Should I use Daniel's Yeah, I use that. A lot of hurry.
Good. Yeah, I'll multiply by r plus 1. I don't know what to do up top. You're right. I have no idea. But you're in agreement with me that we now have r plus 1 factorial down there? Brilliant. Okay, good. Huh? Yeah, I mean, once we're done with all this, we hopefully we get that. Yes. The denominator looks promising, actually. You're right. It's already the denominator we want. That's great.
How does that work?
What did you multiply this guy by? The right fraction? What'd you get? What'd you multiply it by? Farouk? Not quite. Yeah, n minus r, multiplying the top and bottom by n minus r gives, why did you do that? What does it give on the bottom? What's n minus r times n minus r minus 1 factorial? What does that come out to be? Anybody? Okay, I'll write it. Okay, n minus r factorial, how about? Okay, right? Right, isn't that what n minus r times n minus r minus 1 factorial is? Isn't that a thing times the thing 1 less than it factorial?
Sure.
Isn't that, I mean, didn't we already say that this is equal to this times this minus 1? I just ask you to write that as this, right? Isn't this the thing we're saying?
Oh my God.
That's all, right? Can't smiley face be n minus r? Right, that's all I'm asserting, is that if we multiply n minus r minus 1 factorial by n minus r, that we get n minus r factorial. That's all. You see how much power we just had in those two moves? We're in a really good spot now. Do you see why? We have a common denominator. Furthermore, it's also the denominator we seek, isn't it? We're making great progress. You really need to study what we just did, though. Well, we're going to work on that. But do you agree with what we've done so far? Yeah, there's only one rule to apply over and over again. So. All right, what do we get here? So on top, we get this. I still haven't figured out what to do with this, but there it is. over the common denominator that we wanted so badly. Is that all just n factorial, n plus 1 factorial? We hope it is. You said okay. Yeah, I have an urge to factor an n factorial out, don't you? Right. So I guess that leaves in the dust r plus 1 plus n minus r. What is in those parentheses there? What is the numerator there? Is that an n plus 1? How's this feeling, you guys? Isn't that just n plus 1? N plus r minus r. And that's just what? I think we're there, friends. We wouldn't have known we were there. I don't think we would have known we were there if we hadn't written our thought bubble. But I think that's n plus 1. Choose r plus 1, just as we wanted. Now, all right, I want to make sure you see, too, what we just proved here, right? So if n is, again, say n is 4, we're in the row 4 of Pascal's triangle here, then what did we just prove? We said 4, choose, say we pick element 3 or something like that, 0, 1, 2, 3, right? Plus, n choose r plus 1, that is plus, that's 4 choose the next thing, right? Should equal n plus 1, that is row 5. 5 choose 4, right? And isn't that like the defining property that you learned when you were like first learned about Pascal's triangle? Is that this thing plus the thing next to it equals the thing below it, right? So in fact, even though you might not have seen it because of all the algebra, what we're really proving is this kind of like core property of Pascal's triangle that you knew and loved at one point, right? Maybe you've never known that. Okay, there you go, right? Do you follow the algebra on that proof, though? We'll see. See how you do on a couple of these tonight. No, this is not like quiz tomorrow.